Let's talk a little bit about why fiberglass insulation sucks. Fiberglass insulation is almost always poorly installed. That is probably the number one reason why fiberglass insulation, in our opinion, should not be used in mainstream building. Probably anywhere in the country, but definitely not in the Northeast. But most of you probably haven't been in your own attic. We ask that question all the time with homeowners. Have you ever been in your attic? Most of them say no. But if you did a home inspection, you bought a home recently, and you've ever been in your attic, you've probably seen some pretty dirty, nasty fiberglass insulation because, as a rule of thumb, it seems to be used most often in building insulation. But we firmly believe that we should stop providing poor housing to people, and so we're going to talk a little bit about why fiberglass insulation is leading to us providing poor housing to the general public. If you've ever been in somebody's basement and you've seen cobwebs and dirty insulation, it's not because they don't clean their basement. Well, maybe they don't clean their basement. Who cleans their basement? But that cobwebs, the dirty fiberglass insulation, is a product of air infiltration. So what people always talk about their houses needing to breathe. I don't want to build my house too tight because if it's too tight, it won't breathe. But if you actually think about that, where the air infiltration comes in is probably not the air that you want to breathe. So you're getting that leaky air infiltration in through your basement, through your dirty fiberglass, through your attic, through all of that dust, the dirt. If you've ever had a re-roofing project done, you've got shingles and everything else in that space. Do you really think that that's the fresh air coming into your house? So we actually believe in mechanical ventilation because the dirty, disgusting air, especially from fiberglass fibers, which can irritate both your skin and your lungs, dust. Those of us who have done a significant amount of energy auditing have, or at least I know I have, developed a bit of an allergy to dust, spending a little too much time in dusty, dirty, disgusting attics, possibly without a mask on, and we definitely don't recommend that. But I'm going to get a little on my soapbox a little bit here today talking about fiberglass insulation because we think fiberglass insulation sucks. And just to preface this isn't about any one fiberglass manufacturer. This is about fiberglass insulation being installed improperly and in the wrong places for its most effective ways to be installed. So fiberglass is most effective when it has an air barrier on all 6 sides, top, bottom, front, back, everywhere. If the fiberglass insulation isn't in a fully air-sealed cavity, it is not effective. If you're watching the slideshow, you're going to see a bunch of pictures of fiberglass insulation poorly installed. But when you think about fiberglass insulation, we always say that when it's installed in a vacuum, it works perfectly. The glass fibers don't conduct heat, so you're not losing heat through conduction. People think, oh, I have this great fiberglass insulation in my walls. It's reducing, heat transfer through conduction. Yep, talking science here today. But there's also air transported heat loss. And that is actually one of the cheapest ways to reduce the amount of heat loss in your building. It's also something that takes a little bit of time and a little bit of thought, but fiberglass insulation itself does not resist the flow of air. So anywhere that you have a building where all the people who said, I want my building not to be tight, anywhere that you have airflow in your fiberglass insulation, you're reducing its conductive abilities as well as increasing your heat loss by air transported heat, because the fiberglass fibers are meant to trap air pockets, and that's one of the ways that it reduces conduction heat loss. But if you have air infiltration, it takes those pockets of air right through it, which is why you see oftentimes really dirty fiberglass. And that dirty fiberglass is acting more like a filter and less like insulation. So you have those two types of heat loss: conduction through the wall, the surface itself, through the different surfaces and how you've made it up, and you've got air transported heat loss. And for every cubic air infiltration that you have into your home, you have to heat that air. So if it's negative 15 degrees outside and that air blowing into your space is negative 15 degrees, you have to heat that up to 68 to be comfortable in your space. And so that fiberglass insulation is not stopping any of that air infiltration. So current code requirements are 7 air changes per hour. That means the entire volume of the inside of your house changes 7 times every hour. In passive house, net zero, super insulated, the type of structures that we're building, passive houses all the way down to 0.5 air changes per hour or less. So we are providing mechanical ventilation from the places that you want to, straight fresh air as if you had your window open in the wintertime. Most passive houses, super insulated houses, are going to exchange that air with the heated air going out. So it's going to preheat it coming into the space. So it's not coming into your space at negative 15 degrees. And it's a fresh air source as opposed to the source of the air infiltration in the standard house being through your attic, through your wall surface, through your band joist, through your leaky basement area, and through all the dirty areas of your house. So, and we talked a little bit about fiberglass being an air filter, and you'll often hear us talk about how cellulose is our preferred method of insulation. So if we're just talking standard construction every day, the difference between fiberglass insulation and cellulose insulation in a standard 2x6 wall cavity, talking about air infiltration, if you did nothing else, no exterior insulation, no double wall construction, no passive house type wall construction, just change from fiberglass to cellulose insulation. The cellulose insulation has been proven over the years to be able to reduce the air infiltration by about 30%. So we're making the house tighter by about 30%. So we're already having a massive impact on how much it's going to cost to live in this house and how comfortable you are within the house. Nobody likes to sit next to a drafty window or feel a breeze blowing across the floor surface. So just changing out 30% air infiltration reduction, because fiberglass insulation does not stop airflow. Fiberglass insulation, as I mentioned, part of the reason why we think it sucks is because it's almost always installed wrong. So we just talked about air transported heat loss, air movement, and the fact that fiberglass insulation doesn't stop airflow. Oftentimes, the fiberglass insulation, you get to the end of the bat, you're about an inch short, you're like, oh, that's okay, we're just going to sheetrock over it. Well, now you've introduced an air pocket into your cavity, and you've allowed air movement to move through your fiberglass insulation via conduction, via a crack in the building, because after the first 2 years of a new home being constructed, it's going to dry out. And so you've allowed places for cracks in the general building construction to introduce airflow into your fiberglass insulation. You have the same problem if you have a fiberglass bat and it's maybe an inch or two too long, and you decide, well, we're just going to stuff this in the bottom. By stuffing and compressing the fiberglass insulation, you've again introduced air pockets by it being crinkled and wrinkled into the space, but you've also reduced the effectiveness of the fiberglass insulation because it's meant to trap air pockets. So if it's installed within a cavity with an air barrier on all 6 sides, it traps those air pockets within it. But if you've compressed it, it now has less air pockets that it's able to trap. And so you've reduced the effectiveness by reducing the number of air pockets, and you've also introduced an air channel into the space to allow the rest of it to act as a filter. Again, with it being compressed, more often than not, we will see it stuffed behind wiring, because it's easier to just stuff it behind the wire and move on. But Stuffing it behind the wire has it compressed in that channel, and it allows everything from the wire forward to be an air channel to allow for conduction and air movement through the space, through the filter, through the electrical box that's in the cavity. And so that fiberglass insulation actually needs to be sliced at the wire and pulled forward so that it's flush in the space and that the wire is embedded into the fiberglass bat. The same is the case if you have craft facing on that, and then that craft facing needs to be taped and sealed because that craft facing is acting as your air barrier for that pocket or channel. Again, when we're talking about craft facing or how it's installed in a cavity, if it is a faced fiberglass insulation, it needs to be face stapled to the front of the stud, not stuffed into this cavity bay and stapled on the side of the stud, because now we've introduced the channel, we've compressed it into the space, and we've reduced the effectiveness of the fiberglass insulation. Do I sound like a broken record? I feel like I'm repeating myself, but I'm not. Then let's move to the attic and fiberglass bats installed in the attic. You'll often see them installed in between the rafter bays. That's fantastic. That's where they should be installed. But that second layer of insulation, which in the Northeast, you're going to need multiple layers to meet the R49 requirement. If they're not installed in the opposite direction, we just have a channel along the side of each fiberglass bat that comes up beside the stud bay. Because another thing that happens in the Northeast is strapping. We almost always strap our ceilings. So those fiberglass bats aren't sitting on the air barrier, which more often than not is your sheetrock layer. So if those fiberglass insulation isn't sitting directly on the sheetrock, so in full contact with the sheetrock, you have a channel of air that can circulate below your fiberglass insulation, which again is creating an air pocket, air movement, reducing both the conductive effectiveness of the insulation itself and taking the air transported heat loss and pulling those pockets out of it. We then talk about wind washing in the attic, which is where you have a soffit vent and your fiberglass insulation runs all the way up to your soffit vent. But instead of the air blowing up through the soffit towards the ridge vent or the gable end vent, the air is pulled in and across your fiberglass bats, and we call that wind washing. So essentially the cold air that's coming inside, that's supposed to keep the attic cool, is running through your insulation. And in the opposite effect in the wintertime, in the summertime, having that warm air pulled through your insulation is stopping its effectiveness for stopping heat transmission to the attic and through the insulation itself. And so you're getting cool attic surfaces, it's not working as it's performed, and you're getting a lot of wind washing into the space. So people will say, okay, well, if I have strapping, then I can blow in fiberglass insulation. And that is correct. You can blow in the fiberglass insulation. That fiberglass insulation is now sitting on the sheetrock, on the surface of the sheetrock, so that it's in full alignment with what would be considered the air barrier. Whether you have a vapor barrier or an Intello wrap is a whole nother conversation that we'll get into at some point. But that blown in fiberglass, now we're looking at, and this is a problem for bats as well, everywhere that you have an open wall cavity, a plumbing stack, an electrical wire, or an electrical box or light fixture that pops up into your attic. Again, that fiberglass insulation can do nothing to stop the airflow. And everybody learned in science class at some point that heat loss is heat rises. And so it's going to move up through every single one of those openings into your attic. They all act like little chimneys, taking all the heat with it out through your attic. We use the analogy a lot. Maybe it's kind of simplified. Maybe it's a little silly. But in the wintertime, what do you want to always wear when you go outside? A hat and boots. So it's so important to really address both the basement and the attic space. And so fiberglass insulation is not stopping any of this airflow or air movement, and it's reducing the effectiveness, and it's increasing the amount of air infiltration that you have coming into and out of your house. So We feel like the fiberglass insulation is being installed in all of the wrong applications. Your building is going to dry out. It's going to create cracks in your building surface where a cellulose dense packed into a cavity would adjust to that movement of the building structure. It would fill some of those gaps. Your fiberglass insulation isn't meant to do that. So anywhere that a gap appears through a building that's dried out is just going to introduce airflow into your fiberglass insulation. We've seen it installed upside down in a crawl space. When you have craft facing or facing on your fiberglass, that needs to go on the warm surface. So if you've gone into someone's basement and you've seen the craft facing on the bottom side, because it's easy to install that way, it's actually in upside down and it's having the opposite effect that you might think that you want. You've seen it rolled up and stuffed into the band joist, which is above the foundation where your floor system sits on the foundation. This is probably one of the leakiest spots in a whole building envelope. It's tricky to insulate no matter how you do it. And fiberglass insulation is probably the worst thing that you could stuff into a band joist. But again, it's easy. And so easy tends to be cost effective, which tends to lead to a quicker timeline on construction, but it doesn't lead to a better product, a better house, and it's going to cost you money every single year to not take the time to really seal those areas and use something other than fiberglass. It's also where you're going to see really dirty fiberglass. That's probably the one place that most people have seen a dirty fiberglass insulation. And here's me back on my soapbox again. One place that I really hate to see fiberglass insulation installed is in the cavity around a window when a window gets shimmed and put into a space. I'd like to think that most of us have moved past this. The window manufacturers seem to have a monopoly on the market, and that will be a totally different podcast. That might be a month's worth of podcasts to talk about windows, their efficiency, and why it makes such a difference to change your windows or put in really great windows. But in relation to fiberglass, the reason why most people realize a savings around replacing windows in their existing homes is because contractors now are installing the windows with low expanding spray foam around the window instead of stuffing fiberglass into that channel. That fiberglass insulation does not stop air movement. So when you feel those leaks and those drafts around your window, it could be because your window is old, it's performing poorly, it doesn't have a lock so that it closes tightly on itself, or it could be because the pockets around your windows are stuffed with fiberglass insulation, and so the air is just blowing in through all of those construction materials around how your window is installed. So if you want a quick and easy thing to check out, pop a piece of trim off around your window. If you see fiberglass insulation, pull that out, install low expanding spray foam or backer rod depending on how your window is installed, and put your trim back on, which may or may not be as simple as it sounds. But the reason that most people see any kind of major improvement in a window replacement is not from the window itself, but most of the time it's from how the window is now installed versus how we installed windows 10, 15, 20 years ago. Fiberglass is only truly effective when installed in its fully sealed air cavity and enclosed on all 6 sides with a fully aligned air barrier. And when I say fully aligned, I mean I want that insulation to be touching the air barrier, to be touching the Intello, to be touching the sheetrock, to be touching whatever you have decided is your continuous air barrier. And I've gone on and on about why fiberglass insulation sucks. And the truth is we think it sucks. But we do use it in some locations. And so I'm going to talk a little bit about where fiberglass is used in the right place. We build zero energy, super insulated, passive house type structures. And what we've learned over the years is fiberglass insulation is actually a really great sound barrier. It works great as a sound insulation because nothing is worse than building a really tight building, which is now very quiet, and hearing the toilet flush every time somebody goes to the bathroom, and hearing that water run all the way through. And yes, we learned that the hard way. So we use fiberglass insulation to insulate plumbing cavities where we have plumbing running through our walls or through our rafter above. We use it to insulate around the plumbing itself, so they make different fiberglass insulations that fit around pipes and fittings. We use it to insulate ductwork in our attic, which is then covered over with our cellulose insulation, something that's fully fitted to the ductwork that we have. We don't want any kind of condensation in our plumbing. We don't want any condensation in our attic space. We don't want any condensation if we have any ductwork that runs through our unheated attic space. We'd like to try to keep that from unheated spaces as much as possible, but when you have a temperature difference, you could see condensation, and we definitely don't want to see that. We also use fiberglass insulation if we have somebody that's finishing a basement. We might have an ICF foundation or have a foundation that's insulated on the interior, where we run a layer of rigid insulation between the wall itself, the concrete wall, and then we stud frame in the basement, and we create a frame where we run electrical, plumbing, wiring, anything that we need, and then we'll fill those cavities with fiberglass insulation. And again, in this case, when it is sealed on all sides, you don't have that air infiltration against your basement wall. You have a complete air barrier on the front surface. That where it acts as a completely installed barrier. It's cut to the wiring, it's cut around any plumbing or electrical boxes, it's cut so that it fits tightly to everything. There's not a 1/4 inch gap around the electrical box, there's not a compression behind the wiring. It's a great place to increase the R value in a basement area, especially if you are finishing a space, covering it with sheetrock, because it's very simple and cost effective to install in that situation. And lastly, we've used fiberglass insulation in what would be considered a flash and bat method, which means that you have a flashing of spray foam that's thick enough to be past the dew point in your wall surface. So if you have moisture that comes into your wall area, it hits the spray foam and it's still warm enough not to be a condensing surface. This is a way to have a cost-effective installation if you need to, say you need to meet R60 or R50 in an attic, and you have a 2x12 joist, which isn't thick enough to get all of the insulation in it that you need. So you do a flashing layer of spray foam, and then you use a bat layer to the inside of that. Again, the spray foam is sealing the cavity, so you have an air barrier on the outside. It's touching the stud bays on the right and left. It's covered with a sheetrock or Intello or other air barrier on the inside, and it's touching the end of both rafter bays where it's sealed, where you don't have ventilation through that space. And that's really important, is that it needs to be sealed on all ends. If you have a ventilation structure through that, you have soffit venting at the end, you have a ridge vent at the top, you need to make sure that the ends of the fiberglass insulation are sealed just as well as the front and back surfaces, so that you don't have any air infiltration through your fiberglass insulation. So there are a lot of contractors out there who might hate me for saying this, because fiberglass insulation is cheap. Let's be honest, you can go to Home Depot, you can go to Lowe's, you can go to the lumber company, you can buy a roll of fiberglass insulation, you can take it home, you can watch a video on the internet of how to poorly install your fiberglass insulation. So it's cheap, it's cost effective, but we need to be educating our clients and the people that the building envelope is the last place where you want to cut costs, because that will be a bill that just keeps giving. It will cost you more energy every month to live in it, and it'll be less comfortable, and the energy costs will rise. That I can guarantee you. The cost of energy doesn't seem to be getting any cheaper. And I'm saying that fiberglass meets the requirements is a little bit like being an ostrich or believing everything that you hear on Facebook, because we've been doing this long enough now that it isn't new news that fiberglass insulation doesn't necessarily perform the way that it's intended. So let's get the word out. Let's start talking about the fact that fiberglass insulation shouldn't be the first choice. And if you're building a new house, It should be something that you're asking not to have in your general building construction, because it's something that's easy to change. It's something that's easy to do. Cellulose insulation isn't that much more expensive. It does require a little bit more thought. Air sealing is so incredibly important. And it's so much cheaper to live in these houses. But let's not even talk about cheaper, because everybody wants to save money, and saving money is fantastic. But it's more comfortable. I met with somebody who had built a $1 million house. It was gorgeous. It was absolutely beautiful, and it was absolutely freezing. And to live in this house, they had all of the beautiful granite countertops. They have beautiful kitchen appliances. They did all of the finish upgrades, and they didn't realize that by not going to the extent that they could with the building envelope, they were always uncomfortable living in this house. Can you imagine building $1 million house and being so uncomfortable living in it at the end that you don't want to stay there, and you sell the house and you start again? But that's not something that's easy for everybody to do. And just because you can afford the mortgage on a 5,000 square foot house doesn't mean you can afford to heat that 5,000 square foot house. And spray foam isn't the end all be all, so we can't just say, well, let's trade up for spray foam. So why fiberglass insulation sucks? Maybe we're going to have a whole podcast on spray foam insulation, blowing agents. Is it toxic? How does it work? When the building dries out, does it pull away from the studs? Yes, there's a whole bunch of things that we could talk about on that. We can talk about with cellulose insulation. We can talk about how newspaper is no longer a renewable resource. So we'll talk about more information, but this podcast was specifically about fiberglass insulation, how it's installed poorly, which just means that it's never as effective as it says it's going to be, and how every time we see this fiberglass insulation, we're repeatedly seeing higher energy costs, more air infiltration, dirtier air, indoor air quality for people, asthma issues that happen with that. And so let's start talking about why fiberglass insulation should be used where it's most respective of the way that it's designed, and let's stop using it in the building envelope. And my last point on that is fiberglass insulation, when it's installed in a building envelope, is very, very difficult to change after the fact. So if you get into the house and afterwards it's cold, it's drafty, it's leaky, it is the hardest thing to change. But that granite countertop that you have to have is very easy to change out if you can live with another countertop for a year, if you have to save money, or you build your garage next year because the insulation change saved you so much money you could afford to do more improvements. So I always tell people, let us tell you what to do now and what to do later, because installing something in your building envelope that has a major impact on your daily life is a disservice to the general public. So thanks for tuning in today. Again, me on my soapbox talking about why fiberglass insulation sucks. We're glad that you joined us, and we hope that you will come back and join us again for our next show. So have a great day.